Small, and I did Stephen Morris's Why is the Universe Not Boring? He talked about the fact that nature cares about stability before optimality. Nature is going to do what's best for nature and what it wants instead of what we think to be most efficient. Like, for example, this river. The fastest way and the most efficient way would be to go straight, but because of the different banks and the erosion and the way the plates are formed, all different things that affect the shape of the river, it winds. Nature doesn't want what we think is best, so it's going to do what it feels is optimal and what it feels like is the most stable state. The biocomplexity is the study of unplanned interactions from different living organisms. So interactions that you could see planned are the food chain. One animal eating another animal eating another animal. An interaction that you could not see is the effect of how a tree falling in the middle of a rainforest can affect, say, that river. It could diverge it or make it go a different way, or the fact that there are different systems in the Earth. There are different asteroids and different planets that affect our gravity and the moon and the turn of the sun, and that's what the study of biocomplexity is. There's no maximizing state for the Earth's processes, meaning evolving will never end. Such like the sun coming up, the nighttime and daytime, there's always these cycles that will always keep happening. And one day, one thing happens, the next day another thing happens, and especially since there are other things like the asteroid interacting, the changes will never stop. These are things that happen in nature that are natural patterns that we see as patterns, but they can have predicted. Like the first one are some icicles, and the reason it has these rings, as that zoom-up picture has, is the icicle melts a little bit, and then it freezes, and melts and freezes, and melts and freezes, and it makes that crazy pattern. And then the sand dunes are made from winds and a lot of, like the slope of the geography of the gradient, and then these water cusps and mima mounds, and they're all things that we see as patterns that don't really have a reason, but that's just because that nature decided to do it that way. The maps experiment is something that Mr. Morris showed for us, and he mixed two different kinds of sand into one container, mixed it all up, and then poured it down between two sheets of glass. And eventually the sand builds up and forms an avalanching effect, and the heavier granules of sand spread farther than thinner granules, and as you go up, which is kind of not like anybody predicted, it made this striped design. So as he poured, the heavier ones went, and the heavier ones went, and the heavier ones went up farther. And she was just explaining that nature does things that we wouldn't expect, and nature kind of defies what we would assume of it. The Rayleigh-Bénard convention is another thing that he mentioned. What Rayleigh-Bénard saw was that patterns in the cells were running an experiment, and depending on the fluid and temperature, they started making patterns, and they started making circles or whatever. In this case, they are circles, or depending on the speed, the temperature, and the rotational speed, they made hexagons, swirls, and circles. And that's basically the concept of boiling water. So as it's heated up under it, many circles rotate, so the hot water is all almost staying at the bottom, and then it goes up to the cold water, and it goes hot and cold and hot and cold, and it makes many circles. And that's another emergent pattern in nature that we never would have guessed. Along with the Faraday stability. If an open container of fluid is subject to vertical vibrations, it will make a pattern such as circles, squares, and hexagons, also depending on the speed of the vibration at the bottom of the plate and the density and viscosity of the liquid. So there are squares here and hexagons, and some of them made little swirling patterns that moved along depending on the heaviness of the vibration and the viscosity of the liquid, as I mentioned earlier. The pattern formation paradigm. There's open evolution, and we can expect emergence, not design. There's not a set design for nature or anything really in the world, so things happen, and as one thing happens, another thing emerges, and another pattern emerges, and another pattern emerges. So we can't really predict what's going to happen, but we can expect emergence, but we can't expect predictability, if that makes sense. And there's self-organization all along through nature. Like the river that I mentioned at the very beginning, it organized itself by eroding and making that winding path, which is its own organization. And another thing would do another own organization, and eventually that is what makes the groundwork for nature as a whole. Natural complexity is a consequence of physical laws. I think, like I mentioned before, if one thing happens, then another thing's going to happen, and another thing's going to happen. So with one force or action, there's going to be an equal and opposite reaction, and that's what makes nature and complexity of the world that we live in.